So I wanted you guys to go through and to try this on your own for homework, to do the best you could with it. I showed you guys one example in class. So as you see me go through these, this is building us up for what we're going to get into after we review this. Excuse me. It's highly encouraged, folks, and I'm trying to get you to do it all year long, to draw a line when you see a compound, to split apart into your two ions what the compound is. So where will we draw the line when we get to what? After Na3. Okay, so here we go. So look at that second capital letter. After it, it's all one ion, PO4. What is PO4? It's phosphate. So I encourage you again, when you see a polyatomic, folks, to draw your parentheses in, write them in around it, because otherwise you can get very confused. So when we break it apart into their ions. The ions all have a what? Charge. What's the charge on sodium? 1 plus. All right. What state of matter do they now have? Aqueous, right? Because they're dissolving into solution. Dissolution. All right. It says it right in the name, folks. They're becoming aqueous states of matter. All right. And then plus phosphate. And this is where having parentheses around it makes it a lot easier. Many people, as I saw, started working on it. They started doing this, something weird like this. Put a 4 out in front. No, that's absolutely incorrect. All of it. PO4 is one package deal. Stays together. What's the charge on phosphate? 3 minus. And the state of matter is going to be aqueous. So, what's the one last thing I have to do here? Make sure it's balanced. All right, sodium is the piece that is not balanced, so there needs to be a 3 out in front. That's what your net ionic equation would be for the dissolution of sodium phosphate. You're just breaking it apart. There's 3 things that every final answer is going to have, folks. Charges, because they're ions. Net ionic equation, so they've got to have ions, they've got to have charges, they've got to have the states of matter, and they've got to make sure it's balanced. All right, 3 things. That's a point apiece right there. All right, I'm going to go through these last 4 quickly, just to kind of write them in. Draw your line, split it apart. You should have 2 potassium ions that are aqueous states of matter, plus 1 sulfate. Again, it's a 2 minus charge. Another reason why you should put parentheses around your polyatomics is because the charge is over the entire piece. And it's aqueous as well. Potassium hydroxide is going to split up into potassium ion, aqueous state of matter, plus hydroxide, polyatomic, 1 minus charge, aqueous. All right, calcium iodide, Ca, 2 plus, aqueous state of matter, plus 2 iodide ions. Why isn't there a subscript 2 with that iodide? Because it's an ion, right? Why am I even bringing that up? Because what's Brinkelhoff, which are your diatomics, right? Diatomics says we do not have diatomic atoms here anymore. Okay? These are ions. They've gained an electron. They're at a stable octet. They no longer need to bond to be happy to be stable. All right? So they don't. So basically, guys, the way you can remember it is either it's got a charge next to it or it's got a subscript. It's one or the other. It's not going to be both. Okay? It's not going to be both with your Brinkelhoffs. It's either a charge or it's a subscript, one or the other. And the last one, magnesium nitrate, Mg2 plus, aqueous state of matter, plus 2 nitrate ions with a minus 1 charge. Are there any questions on that practice that you had from last night? My hope is that it was super easy. Folks, this is really what we're going to be doing here with these net ionic equations. But they're going to get more complex and more challenging. There's a process you've got to follow. If you skip steps, you're going to be confused and the final result will not be correct. All right, so there are steps for solving net ionic equations. If there's no question of this, flip to the next page in your notes. To where it says net ionic equations. You will see me style that like this, NIE. All right, I would encourage you guys to write that in there. A lot of times I'm going to write NIE in there. These are the 4 steps. First things first, if you are not given a balanced equation, you have to write a complete balanced equation. So as we saw from the bell work yesterday, I may give you reactants, and you guys have to identify the type of reaction, predict your products, and then balance it from there. That's the first step. Then, step 2, we're going to use our solubility rules to determine their solubility. This is where we're going to write what's called a CIE. What CIE stands for, guys, is complete Ionic Equation. Complete Ionic Equation. So again, I will a lot of times write that, and you'll see what I mean in just a minute. We've got the balanced equation, the complete ionic equation, and then we have the net ionic equation. So we can only break apart, though, soluble pieces. We can only break apart soluble compounds. They have to have their charges, because again, they're called what? Net ionic equations. They've got to have charges. We're going to leave the insoluble compounds together. How do I know if something is insoluble? Okay, well, I'm going to use my solubility rules, but let's say I've already done that. I'm just looking at the equation. How do I know if something's insoluble? Not aqueous. It's anything that's not aqueous. So it could be solid. A lot of times, most of the time, guys, it's going to be solid state of matter. But it's anything that is a not aqueous state of matter. Anything that is not aqueous. And that's something big to remember. It could be gas. It could be liquid. All right. Most of the time, it's going to be solid. And what do we call a solid that forms in a reaction? It's a precipitate. All right, so a lot of times it's going to be those precipitates that we're looking at, but it doesn't have to be. It could be anything. It could be any state of matter as long as aqueous are the only ones we can break up. So then we're going to cancel out spectator ions. Because what are spectators, folks? Like in the world of entertainment, what are spectators? They just look, right? They're sitting there comfortable in the stands in their luxury boxes, with food and drinks being brought to them. All right? Anybody ever been in a luxury box? It's actually pretty awesome. All right?
Go to the circus.
The circus? They have luxury boxes at the circus? Did not know that. That's pretty crazy. Did not know that. But anyway, folks, spectators, they're just sitting there, not doing anything. They're not down there in the action. They're not the players. Okay? What we're interested in, though, in net ionic equations, we're interested in the ones that are active, the ones that are actually reacting together to form something new. Okay? So we're going to cancel out spectator ions. Then we're going to write our final equation. Notice what it has to have. Must include states of matter. If you don't have states of matter, it's going to be wrong. From here on out, the rest of the school year, folks, until June, you have to have states of matter. And that's called our NIE, our net ionic equation. Again, we can talk all day long about steps, but until we actually start to use them, they're not going to make any sense. So we're going to jump right in, guys, to some practice here. So we've got to write all 3 lines. You guys are not experts at this. All right? It takes a lot of practice to become an expert at it. So there's going to be 3 different lines that we're going to write. First things first, what do we have to do? Before we balance it, predict our products. That is the first thing we have to do here, folks. So, what type of reaction do I have? Double replacement. Okay, we've got a double replacement reaction. What does that mean with our pairs here? They're going to switch partners, okay? So drawing your lines may help, okay? Who's AG going to go with? Chloride. What's NO3 going to go with then? Okay, so those are going to be the ones that go together. If it helps you guys to draw your lines out like I am, I encourage you to do so. All right? But I'm just going to go ahead and write my products, and you'll see me rewrite. I encourage you guys to use a separate sheet of paper with your notes right now. All right? Get it out. Go to your notebook. Rip out a piece of something. I've got computer paper. You want a lot of space for this, and you'll see why after we go through and write the lines out. I highly recommend using a separate sheet of paper for your notes here, unless you printed off a full-page version of the note packet. So what I'm going to do first is I'm going to write my balanced equation. So I encourage you guys, the lines that I'm about to write, you need to write them as well. We're going to have 3 lines. We're going to have a balanced equation. We're going to have a CIE, which was our complete ionic equation. That's going to show all of our ions. And then our final line is going to be the net ionic equation. What does net mean again? Not all of them. Think about it, right? If you have a Facebook, or not a Facebook, if you have a paycheck, okay? If you have a paycheck, the net pay is what you actually take home. It's what everything's taken out. I don't know where that came from, all right? I don't know where that came from. I don't. Anyway, moving on. Guys, your net pay is what's taken out after taxes and insurance and Medicare and Medicaid. All that stuff is taken out. All right, you're left over with your net pay. So, our balanced equation, we've got silver nitrate. So the reactants already given to us. We don't have to worry about those. Plus MgCl2, magnesium chloride. Now, what are our products going to be? So, what do we have to go back to every single time? Go back to your crisscross method. What's the charge on silver?
That would be
+1. Chloride is going to be?
-1.
1-. So our formula then from those two ions is going to be what? AgCl. All right, plus, go back to your charges. Do the crisscross method. This is where you can't cut steps, guys. I'm telling you. If you cut steps early, everything else is going to be messed up. Okay? So take the extra 5 to 10 seconds to write out your charges. Magnesium's charge is what? 2+. Nitrate's charge is 1-. So, crisscross those over. All right, we get MgNO3 in parentheses with a 2 on the outside. Last step is what? Balance it. Okay, so I'm going to balance my equation. How do I do that?
Well, you gotta have 2 NO3s on the left side.
So 2, 1, 2, 1. Now, again, it could have been different if you changed the order of your products, guys. That's fine. You could have had AgCl at the end, magnesium nitrate first. That's fine. All right. Have we done anything new yet? No. Okay, so our next step we have to do is what? That's step 1. Look back at your notes.
Complete ionic equation.
Before the complete ionic equation, we have to determine the solubility. So, guys, this is where your solubility rules come into play. I want you guys to go through, assign your states of matter to every single one of those. All right, silver nitrate. Solubility is going to be aqueous, right? All nitrate compounds are soluble. MgCl2 is going to be aqueous as well. Silver chloride, solid. Magnesium nitrate, we just said all nitrates are soluble, so it's AQ. Folks, we see something has changed, right? We took two solutions, we mixed them together in what form? A solid, which is called a precipitate. So a precipitate form, which is silver chloride. Question?
Why did you put aqueous if it also has silver and the rules say it can't be silver?
Nope, the rules don't say that. The rule for nitrate. So you got to look at your anion first. Are there any exceptions there? Silver, it's not every silver compound. All right, it's only when it's with chloride. Okay, so those exceptions are very specific. Don't assume, guys, that they are for everything. But I'm glad you asked that point there, Riley, because people have been confused about that in all of my classes. All right, so what we're going to do now, I'm going to use a different color. You don't need to. All right, it's up to you. What I'm going to do now, guys, is we're going to split up our compounds. But what are the only ones that we can split up? Aqueous are the only ones. So I'm going to draw arrows. Early on, the first couple examples, I'm going to draw arrows to show you where the pieces are going. And this is the one that gets very long because it's the complete ionic equation. So, folks, what that means is you're showing show all ions. You're going to show all of the ions that are there. What substances form ions? The ones that are what state of matter? Aqueous. So, I'm going to draw my arrows here. So, I'm going to get silver. Ag, we said, was 1+. Aqueous state. How many silver ions do I have? 2. Why? Yeah, because there's a 2 right here. Okay? Now, is that 2 only for silver? No, guys, it distributes out to both ions. I'm going to have 2 moles of silver ions, and I'm also going to have 2 moles of nitrate ions. This is where things start to get a little confusing. So I've got 2 moles of nitrate ions as well. Is everybody kind of tracking with me what I've done so far? I've just dissolved my compound, guys. I've just split it apart into the ions that form when that substance is mixed with water. Okay? And the 2's, they come from the coefficient. We can't lose that. So plus, my next one, can I split up my next compound? Yes, I can. All right, so are there any coefficients that go out in front of these? No, there are not. How many chloride ions do I have? 2. How do I know I have 2? Because there's a subscript 2. So where does that 2 going to go now? As a coefficient, guys. If you have a subscript, like we have in chlorine here, it becomes a coefficient when we write the Ionic equation. Why? Because you can either have a charge or a subscript. You can't have both. All right, you can't have both. So those are all my reactants. All my reactants in this reaction, folks, they are split apart. They form ions because they're in solution. Am I going to split apart silver chloride? No. So I'm just going to drop that down as I see it. 2 AgCl solid. Plus, can I split up my last piece? Absolutely. So I've got Mg2 plus aqueous plus 2 nitrate ions. And my aqueous doesn't fit, but it should go after it. I ran out of space. So before we go on any further, is everybody with me kind of what we've done so far? Yeah. All we've done, guys, is we've split apart our aqueous solution pieces into their individual ions. Because when you mix something in solution, that's exactly what happens. They form ions. All right, they form ions. Because we've talked about electrolytes before. Electrolytes do what? They conduct electricity. Why? Not negative charge. They just have charges. Okay, electrolytes, guys, when they go into solution, they have charges. That allows those electrons to flow. Remember I showed you guys the light bulb, and I stuck it in there, and it lit or it didn't light up? All right, it's because of the charges. All right, so there's step 1 and 2. What is our next step? Net ionic equation. So, folks, the net ionics. This is where, okay, the complete ionic equation is like your gross pay. All right, in your paycheck. It's everything that you've earned. Now, the government's going to come along. They're going to take out your taxes. They're going to take out insurance. They're going to take out everything. And you're just going to be left with what's left over, which is your net pay. Okay? So we're going to start slashing things. The only things that we can slash, folks, are if they are exactly the same on the left side and the right side, the reactants and the products, because they're the spectators. They didn't change. They didn't take part in any action. We're going to get rid of those. So, here we go. Let's take a look at the first one. Silver, the silver ion. Do we see 2 Ag plus aqueous on the right? No, so we're going to keep that because that took part of our reaction. Do I see 2 NO3 minus aqueous? Yes, so I'm going to cross that out from both sides. They stay the same. They're not going to be dropped down. Those are like our taxes getting taken out. Do I see Mg2 plus aqueous on the left and the right? All right, so those are going to get crossed out as well. And you guys should actually cross them out with your pencil too, just like I'm doing. Do I see 2 Cl minus aqueous on the right? No. So folks, everything that was, we've gone through and slashed out the taxes and the insurance and all that other stuff, okay? As we've taken those out, everything that's left over is active in the reaction. It's what has changed states. That's our reaction. So we're going to go through and we're going to write out everything that is left over on the bottom. All right, this is our net ionic. You're going to drop it down exactly as you see it. So it's 2 silver ions that are aqueous state of matter plus 2 chloride ions. Aqueous state of matter yields 2 moles of silver chloride. And that's a solid. That is how you write a net ionic equation. All right, here we go. Go ahead, guys. Predict your products. You should be able to do that on your own. When you go through, guys, and you pair up who goes with who, right? Double replacements like square dancing. You're switching partners. All right. I wrote out all the ions. It's a good habit to get into. because you're going to be looking at the ions at some point, so you may as well just want to split them, write them at the top so you can look back at them. All right, these are what you should have. Now, what do we know about HOH there? It's really H2O, guys. So as far as balancing, remember I told you way back when we did balancing equations, writing it out or leaving it as HOH can make your life easier when you go to balance. However, with these, I would encourage you guys, once you have it balanced, to rewrite it as H2O, and you'll see why in just a minute. So when I balance this equation, what are my coefficients going to be? What goes in front of HNO3? 2. What goes in front of BaOH2? 1. What goes in front of water? 2. What goes in front of BaNO3? 2. 1. So, it makes sense, maybe it helps you out, I know it does for me, to leave it as HOH when I'm balancing, but then you want to go back, you don't have to, but it may help you out, may go easier then to see what's going on for your net ionic, to rewrite it as H2O. Now, states of matter. What's my state of matter for HNO3? Aqueous. All nitrates are always aqueous. Barium hydroxide is aqueous. Skip over water for right now. Barium nitrate is aqueous. What is H2O going to be? Why liquid, folks? It's not, okay, it could be, not that it's hydroxide, all right? It is a universal solvent, but what about it? Why is it liquid and not aqueous, folks? Because what is our definition of aqueous? It's called an aqueous what? Solution, and the solution is a what? It's a mixture, guys. Is water a mixture? No, water is a pure substance. That's why it gets the liquid state and not aqueous, because it's a pure substance. That's why everything else, guys, has to have aqueous. It's not a pure substance. So, now we're going to go through and break apart our ions. I'm going to, again, change up color. Can I break up nitric acid? Yes, because it's aqueous. So, what do I get? What are my ions going to be?
2H.
Just 2H? 2H with a plus sign. Aqueous. Plus what? 2NO3 minus aqueous. Good. Remember, again, this distributes out. Coefficients do. Plus what? 2 plus aqueous. Plus what? 2 hydroxide ions, aqueous. Yields, can I break this apart? Can I break water apart? No, why not? Because it has a liquid, guys. So if you leave it as HOH, you may fall into the trap thinking, oh, it's hydroxide, it's soluble. But folks, it's water. Water is a pure substance. It's a liquid. It's not a mixture. So we have water, 2 waters. It's the liquid state. That's the key here. You could see this one on your test, on a quiz, on your final exam. All right, they will throw water in there a lot of times. You've got to recognize that, hey, it's water, it's pure, it's liquid, it can't be broken up. And then you're going to have plus Ba2 plus aqueous plus 2 moles of nitrate ions, NO3 minus, and aqueous should be at the end again. Okay, ran out of space. So, our next step, once we have our complete ionic equation, is to do what? Cancel out the spectators. Go and slash. Can I get rid of my hydrogen ion? No. Can I get rid of nitrate? Yes, it's the same on both sides. Can I get rid of barium? Yes, I can. It's the same on both sides. Can you get rid of hydroxide? No. So now our final piece that we're going to go ahead and write, we should just drop everything straight down that we have left over. 2H plus aqueous plus 2 hydroxide ions, aqueous, yields 2 moles of water, liquid, and that is your net ionic equation there in the end. It's a long process, folks. The only way it gets easier is if you practice over and over and over again. So, for homework on that page, I want you guys to try number 3 and number 4. 4 there to give it to you, everything you don't have to predict. So try numbers 3 and 4 for homework. You also have a problem set due tonight at midnight. Try number 3, guys. And I'm telling you, if you don't